we go. Systems of inequalities. So a system of inequalities is just more than one inequality. And when we graph more than one inequality together on the same graph, what we're going to be looking for now is not just a line with shading on one side, but two lines, both shaded. And the question is, where do they overlap? So where does the shading of one overlap the shading of the other? Let me show you what I mean. So here's an example of a system of inequalities. And just so you know, this is the first one on your homework. So as you're doing your homework, look back at your notes, and you can just copy down the answer onto your homework. So I have two inequalities here. These are both in y equals or slope-intercept form. So I'm going to graph them in the same way. First, I'm going to look at the y-intercept. In the first equation, it's negative 2. So I go down 2 on the y-axis and make a dot. Actually, I'm going to graph this one in blue. Blue is not working very well. Alright, so down to, so this equation will be in blue. Down 2 and make a dot. Then I look at the slope. The slope is just a negative. So that's the same thing as negative 1. I'm going to go down 1 over 1. And then this says equal to, so I'm going to make a solid line that connects those 2 points. So this is not really new, right? I'm just graphing this inequality same way we would graph a single inequality. The last step is to find which side to shade on. So I'm going to plug in this point here, 0, 0. 0 is less than or equal to 0 minus 2.
Nice.
0 is less than negative 2. Doesn't sound correct to me, so I'm going to shade on this side. Right? And actually it's helpful if we write that out. 0 is less than or equal to negative 2. That's false. The reason I encourage you to write this out, you might have plugged in 0, 0 correctly and just not realized that whether it was true or false. Or you might have even realized that it was false, but somehow you shaded on the wrong side. On a quiz or a test, I'm not going to take off very many points if you show all your work and then you just shade it on the wrong side. Right? But if you don't show me any work and you shade it on the wrong side, then I'm going to take off like half points for that question. So I really want you to show me as much work as possible. Now on this same graph, I'm going to graph the second equation. Y is greater than or equal to negative 5x plus 2. So again, I start with my y-intercept. I'm going to go up 2 on the y-axis. And then I look at my slope. Negative 5 is the same thing as negative 5 over 1. So I go down 5, 1, 2, 3, 4, 5, and then over 1. That's kind of interesting. That point is the same as my point for that graph. There is an equal to here, so I'm going to make a solid line that connects those 2 points. I can see that 0, 0 is on this side. That's a good point to plug in. Is 0 greater than or equal to positive 2? No.
No.
That's false. So I'm going to shade away from 0, 0. Now, if I were doing this without colors, what I might do is shade one line kind of this way that I shaded it, and then shade the other line like the other way. So instead of shading away from the line, I would shade next to the line. That's another way of graphing these. And then what I'm looking for is the area where my two shading regions overlap. So I'm going to circle that in red on this graph. In this case, I can see pretty clearly the green and blue overlap in this region here. Right? That's where I have my overlap. So this is my solution. What I want you to do on your homework tonight is you can just draw a little arrow off to the side and say solution region. Do you see that when I have two lines that cross, there will always be four possible regions? Here's one of them, in between this blue line and this green line. This region over here is bigger on this graph, right? All the way from here to there. That's another region. Then I have this region here where there's no shading at all. And then the fourth region is this region here that only has blue shading in this graph. So you're always going to have four solution areas. One of them is the correct solution. And that's where both shadings overlap. Yeah.
On our homework to identify each different line, can we use something like color pencils or anything?
Yeah, I would love it on your homework if you would use color pencils.
That's what I was asking if I could do.
That would be great. If you don't have color pencils at home though, just do what I said before and shade. So let's, like if I were shading this blue one, I could shade it. I could shade it in this direction, right?
A different direction than the thing. Yeah.
And then what I can see is that my solution region will have lines that cross. You guys see that? Because I shaded the blue one sort of parallel and the green one perpendicular. So in the solution area, the lines cross and make boxes. Whereas where there's not a solution, I just have lines going in one direction. And there will always be a region where you have no shading at all. On this graph, it's this area. That's it. That is how you graph a system of inequalities.
This is cool. I like this thing. It is cool.
I think this is one of the coolest topics
I can see why you think
in
that.
algebra.